Now let's see how to solve the numerical based on the Faraday's first law of electrolysis and second law of electrolysis in a very short time. That means in exam. Now generally the numericals are asked the Faraday's first law of electrolysis or the second law of electrolysis, which talks about the amount of the substance deposited. Let's solve the numerical based on the Faraday's law of electrolysis by using mole concept. Now, which type of numericals are asked generally? Generally the questions, like as I said, here we are talking about the Faraday's first law of electrolysis or the second law of electrolysis tells us that how much substance is formed is directly proportional to the amount of electricity is passed through it. So we consider the same concept, that is electricity passed will decide the amount of a substance. Now when I am saying that amount of electricity, then in what quantities this amount of electricity can be given? This electricity is given sometime in Faraday, sometime it is given in coulombs, sometime it is like I into T format. Then I into T format, it may be possible that both I and both T will be given, or sometime what happen, I will be given, the time will not be given, or the time will be given and I will not be given. Then amount of substance, the amount of substance, that is I can say like moles, the unit, which is measured in 3 terms, or in 3, we use a 3 different method for measuring the 3 different quantities for measuring the amount of a substance. One is a mass, second is a volume, and the third is the number of particles or the number of molecules. So question will involve these things only. Now let's solve the first numerical. The question is that if I am passing 5 Faraday of electricity, then how much gram of aluminium will deposit? This is the question. It will be written in the proper manner, but the thing is same, that is if you are passing a 5 Faraday of electricity, then how much gram of aluminium will deposit? Then I can say that 1 Faraday will be equivalent to its equivalent mass, then 5 Faraday will be equal to the 5 into equivalent mass. Or I can use a mole concept. Then in mole concept, simply I will say just write the reaction for the formation of aluminium as fast as possible. Then aluminium will carry 3 plus charge. So here I can say that aluminium plus 3 electron will give you aluminium. That means I can say that if you are taking 3 moles of electron, then 1 mole of aluminium will form. 3 moles of electron, that means I can say that 3 Faraday of electricity will form 1 mole of aluminium. 1 mole of aluminium, here I want gram, mass. Then convert that moles into mass. Now 1 mole of aluminium means how much gram aluminium? Then atomic mass of aluminium. 1 mole, that means equivalent to its atomic mass. If it is a volume, then 1 mole, that means it is equivalent to 22.4 dm cube. And if it is a number of molecule, then I can say 6.02 into 10 to 23 molecules. So 3 moles, that means 1 mole aluminium. So 1 Faraday will be equivalent to, I can say, 1 by 3 moles. So 1 Faraday is equal to 1 by 3 moles means 27 upon 3. That means I can say 9 gram aluminium. So if you are passing 1 Faraday of electricity, then 9 gram of aluminium is formed. Then 5 Faraday of electricity will form how much aluminium? Then simply I will say that 45 gram of aluminium. So this is the answer. Then second numerical. The question is that if I am passing 1,93,000 coulombs of electricity, then suppose the chlorine gas is evolved, then how many chlorine molecule is evolved? The question is, that means how many molecules of chlorine is evolved here? Simply again write down the reaction for it. Cl2 is forming, that means in a solution there will be a Cl minus, and that Cl minus will give you Cl, but we know that Cl2 form, that means 2 Cl minus will be needed, so 2 electron. So I can say that 2 mole electron is equivalent to 1 mole chlorine. Now here I want this Cl2 molecules. So convert this mole into molecules. So 2 mole electron, that means 2 Faraday, but here it is in coulomb. So 2 Faraday means I can write 2 into 96,500 coulombs. So I can say that it is equivalent to 1 mole chlorine, that is 6.022 into 10 to 23 chlorine molecules. 2 into 96,500, if you multiply, you will get the same number. 10 to 23 molecules. Third question. "800 coulombs of electricity will produce how much grams of magnesium?" 800 grams of 800 coulombs of electricity. Then simply write the reaction for the magnesium. Then I can say that magnesium 2 plus. In iron form, magnesium have plus 2 charge will form magnesium. That means I can say 2 moles of electron is giving 1 mole of magnesium. 2 moles electron is equivalent to 1 mole magnesium. That means 2 mole means 2 into 1 Faraday. 1 Faraday is equal to 96,500 coulomb. I can say 1 mole means 1 Faraday. 2 moles means 2 Faraday. That is 2 into 96,500 coulombs. Is equivalent to 1 mole magnesium. Here I want the mass of magnesium. So convert this mole. See, depending on what quantity is asked, on that basis we convert the mole into either mass, volume or number of molecules. So here the gram is asked. So convert magnesium into gram. That is 12 grams of magnesium. So if I'm passing so much coulombs of electricity, then 12 grams of magnesium is formed. So if I'm passing 800 coulombs of electricity, then how much magnesium will form? And simply I will say x gram. Find out x value. So x is equal to 800 into 12 upon 2 into 96,500. And after solving, you will get some answer. Grams of magnesium. Similarly, let's see the fourth numerical. We did 3, fourth one. Some coulombs of electricity is passed so that 56 dm cube of oxygen gas is produced. 56 dm cube of oxygen. Now from where oxygen we get it from OH minus ion. When OH minus ion undergoes oxidation, we get O2. Now for simply I can say that if O2 is forming, then O2, each oxygen carry 2 minus charge. That means 4 OH minus ions will be there, which will produce 1 O2 and 4 electron is liberated, and plus we get water also. So just keep in mind that each oxygen carry minus 2 charge, so there is a 2 oxygen, so it will lose 4 electron. So simply I can say that 4 electrons, how much coulombs of electricity are required? So here I can say that if I'm like 4 electrons, so 4 moles of electron, that means 4 into 96,500 coulombs is equivalent to 1 mole oxygen. 1 mole oxygen in dm cube I want. So in dm cube it is going to be 22.4 dm cube. So x coulomb will produce 56 dm cube of this. So here x is equal to, I can say that 4 into 96,500 into 56 upon 22.4. 4 5s are 20, 4 6 are, this will give you 10. So I can say that 96,500 into 10 will give you some answer. Then similarly, question number 5. Now here certain amount of current is passed for 100 seconds. So we are getting 56 grams of copper. So 56 grams of copper. So here ultimately I want I can say. So how to write? Now for copper, just write down the reaction. Cu2 plus 2 electron will give you Cu. So I can say that if you are passing 2 moles of electron, then copper produced is equal to 1 mole. 2 moles of electron, therefore I can say 2 into 96,500 coulombs is equal to 1 mole gram. So it's a 63.5 gram copper because the atomic mass of copper. So I can say that if I'm passing I into 100 seconds, then it is equal to 56 gram copper like this. So I is equal to cross multiply, that means 2 into 96,500 into 56 upon 63.5 into 100. So you will get a value for I also. Then question number 6. Then 69 grams of magnesium is deposited. Now how to solve this question? Then simply I will say again the same thing. Magnesium, then formula reaction will be magnesium 2 plus 2 electron will give you magnesium. That is 2 moles of electron will form 1 mole of magnesium. So 2 into 96,500 coulombs. Whenever IT concept is used, you have to consider the coulomb. Gram is given, so 12 gram magnesium, that is 1 mole. So 5 ampere, that is 5 into some time, is equivalent to 69 grams of magnesium. So again, to get the T value, simply I will say cross multiply, that is 2 into 96,500 into 69 upon 12 into 5. After solving, you will get some value, that is a time in seconds. The time will always in seconds. So this is the way how we solve the numericals based on the first law of Faraday. Now after this, we will see how to solve the numericals based on second law of Faraday. Now let's see the numericals which are asked on the basis of the Faraday's second law of electrolysis. As we know that the Faraday's second law of electrolysis states that when the same amount of electricity is passed through the different electrolytic solution, the amount of substance deposited directly proportional to the equivalent mass. Means here we are simultaneously passing the electricity from the two different solutions. So generally in this case what happens, they say in a question they gives the amounts of the one substance and they ask the amount of the other substance which is deposited in a second electrolytic solution or second electrolytic cell. For example, suppose the question is like the 56 gram of, if on passing electricity, there are the two containers, the two electrolytic cell. The one is containing a zinc sulfate and the other is containing copper sulfate. So when the electricity is passed, the question is that 56 gram of copper is deposited. So if the 56 gram of copper is deposited, that means how much grams of zinc will deposit in another container. When the same amount of electricity is passed, which deposited 56 gram of copper, then the same amount of electricity will deposit how much gram of copper. So simply I will say that here let's do the same calculation for both copper as well as zinc. So here the copper has been deposited, so the reaction is going to be copper 2 plus 2 electron will give you copper. So I can say that if 2 moles of electron gives 1 mole copper, that means if 1 Faraday electricity or 1 Faraday electricity will form half mole copper. Half mole means 2 Faraday will give you 1 mole, so 1 Faraday will give you half mole. Half mole means I can say 1 Faraday will pass or it will produce copper 63.5 divided by 2. It will give you approx 31.7 gram copper. Similarly, let us do the same thing for zinc. So here I can say that if I have zinc 2 plus 2 in solution, it will be zinc ion, so will produce zinc metal. So I can say that if 2 moles of electricity is passed, then zinc produced will be 1 mole. 2 moles means 2 Faraday of electricity, so 1 mole of zinc has been deposited. So if I am passing 1 Faraday electricity, then half mole zinc will deposit. 1 Faraday, that means half mole, means I can say that here the zinc deposited is half of 65.4, that means 37.2 gram. So here I can say that if I am passing the same amount of electricity, let us say I pass 1 Faraday electricity. So how much gram copper? It will deposit 31.7 gram copper. And how much zinc? So I can say that it will deposit 37.2 gram zinc. Right. So now let us consider this much area, this much part only, that 31.7 gram copper, when 31.7 gram of copper is produced in first cell, then at the same time 32.7 gram of zinc will produce. It's a 32.7. So 32.7 grams of zinc will produce in other container. So if 56 gram of copper is produced in first electrolytic cell, then how much zinc will produce? Cross multiply, so 56 into 32.7 upon 31.7. The answer is going to be slightly greater than 56. So some gram, you will get some answer of zinc. So this is the way how to solve the numerical based on the Faraday's second law of electrolysis in a very small time. Then second one, once you start practicing, it will take hardly some seconds for the completion of such numericals. Now let us talk about the second. Now let's see the second question. The second question is that how much gram of copper is deposited if 216 grams of silver has been deposited in another cell. So on passing the same amount of electricity, the 216 grams of silver has been deposited. So how much gram of copper will deposit? Similarly, fast just write the reaction that I can say that Cu2 plus 2 electron will give you 1 mole of copper. So I can say that 2 Faraday will give you 1 mole copper. So I can say 1 Faraday will give you half mole copper. So 1 Faraday will give you half mole copper means 31.7 gram, that is 60 half of 63.4. Similarly, I can say for silver plus 1 electron will give you silver. So 1 mole electron will produce 1 mole silver. 1 mole electron, that is 1 Faraday. 1 Faraday electricity will give 1 mole silver, that means 108 grams silver. So here I can say that when 1 Faraday of electricity is passed, 31.7 gram copper is formed, and in a silver container or a cell, I can say that 108 grams silver has been deposited. So now let us talk only this much part. So if 31.7 gram of copper is deposited, then due to the same amount of electricity, 108 gram of silver will form. So let x gram of copper is deposited in first container, when in a second container 216 grams of silver has been deposited. So x is equal to cross multiply, then I can say 31.7 into 216 upon 108. Twice, so I can say that it is going to be 63.5 gram copper. So in this manner we can solve the numericals which are based on the second law of electrolysis.